All right, so today is your first day actually getting to take notes. So we're actually doing this one as a whole group, and so you kind of get the feel of it before I send you off to do it by yourself. Now, if you notice, on most of our notes, you will have some basic vocab at the top of the page. These vocab you will write in your vocabulary dictionary as well, but we're going to write short definitions up at the top just to help you remember what the vocabulary is and how it applies to this particular lesson. And so the vocabulary words that we're focusing on is real number, natural number, whole number, integer, and rational number. Now, anything I write, you write. So even if it's little, if I'm writing it, you should be writing it. Just the number at the top of the page, you should have written that already. All right? So first thing is a real number, which are numbers we normally use, okay? Numbers we normally use. And that can be positive or negative, large or small. And so this graph down here is going to be considered the real number boxes, okay? We're focusing on the real numbers. Next we have natural numbers, which are our counting numbers. Okay? These are our counting numbers. When you count to 10, 1, 2, 3, 4, the natural numbers. Whole numbers are the same thing, but they include 0. Okay, they include 0. But these two are very similar. Okay, natural numbers and whole numbers. And neither of these allow negatives. Okay, negatives are a no. Next we have integers. And integers are whole numbers. But these are the positives and the negatives. And so on these two, negatives are no, but on integers, negatives are good. Thumbs up. Okay, also include 0. And 0. And last we have rational numbers. Rational numbers, you will actually have a whole page of notes that focus on rational numbers. Rational numbers are any number that can be written as a fraction. Any number that can be written as a fraction. Using integers. Okay, so if you need to pause and finish writing, now would be the time to do it because I'm going to move on. But that's the best thing about the videos is if you need to pause it and catch up, feel free. Moving on, we're going to come down to our boxes. On our boxes, the first box down here is going to be our natural numbers. Our natural numbers are our counting numbers. 1, 2, 3, 4, 5, 6, 7, and so on. These would be our natural numbers. From there, I'm going to switch colors to help you see. From there, we move on to whole numbers. And our whole numbers include our counting numbers. If you notice how these boxes work, each box is inside the bigger box. So if it's a whole number, then it's also a natural number. Okay, and if it's an integer, it's also a whole number and natural number. It builds on itself. Whole numbers should be numbers like any of the natural numbers, 1, 2, 3, 4, 5. They could also be 0. That's the difference, is a whole number includes 0. Where natural numbers, you don't usually start at 0 when you start counting. You start at 1. It also includes, here's a weird one, if you have 4 over 2. If you had 4 over 2, it looks like a fraction, but if you simplified that, you would get 2. Simplified 4 halves is 2, which means that 2 is a whole number. So 4 halves would be a whole number. Also, this year we're going to be learning about square roots. A square root looks like this. And so if you had a square root of 25, that would be a number times itself that equals 25. So what number times itself equals 25? And the answer would be 5. And 5 is a whole number, which means the square root of 25 would be a whole number as well. Okay, the next section is integers. Integers, and remember we talked about that an integer is also a whole number and it's also a natural number. Integers include them all. An integer is almost the same thing except for it includes negatives. So you could have a -3, you could have a positive 400 or 123, you could have 0. And an integer would also include something like this. So if you had, for example, 10/5. 10/5, although it looks like a fraction, if you simplified it, it would give you 2. And 2 is a whole number, which means it's also an integer. The difference is an integer, this could be negative 10/5, which means this would be a -2. And a -2 or -3 would be an integer. But negatives can't be whole numbers. Negatives can only be integers. And the last section is rational numbers. Rational numbers should be the newest for you, because all of these should have been pretty common. But rational numbers include fractions and decimals, because decimals can be written as fractions. Okay, so if you have a rational number, might be 1/2 or 0.5, because 0.5 can be written as 1/2. And if it can be written as a fraction, then it's a rational number. And so you have 1/2, 0.5, 0.37 is rational because that would be 37 over 100. So see how decimals can be rational as long as they can be written as a fraction. And anything that can be written as a fraction can also be an integer usually, because 1 is the integer and 2 is the integer, but 1/2, which is half of a whole, would just be rational. Also, these can be negatives, so this could be a -37 over 100, or you could have a -1/7. Any of those would work. Okay, now we're going to cover one last area, although you won't actually learn too much about it this year, and it's an irrational. If we have rational, obviously we have to have irrational numbers. Next year you'll focus a lot more on irrational, but today we're just going to introduce it. An irrational number can't be written as a fraction. As a fraction. Okay, it can't be written as a fraction. It also can't be divided by 2 integers, which means it can't be written as a fraction. An example of this one would be pi. Pi is 3.14159 forever. Okay? And it's not repeating. So you can't write this as a fraction because it never ends. Another example might be if you had 0.1010001000 dot dot dot. It just kept continuing. Because it's not repeating itself, and because it goes on forever, you cannot write it as a fraction, in which case it would be an irrational instead of a rational number. Okay, so now if we look down here, we're going to go, you have together and you have a practice. Your together are the problems that I'm going to do with you, and your practice is what you need to do by yourself. And so 3.4, we're trying to determine what kind of number it is. Because there's a decimal, only rational numbers can be decimals, and so it's a rational number. Next is 1/2. No fractions, no fractions, no fractions, so it has to be a rational number. Next we have -5. So natural numbers can't be negative, whole numbers can't be negative, but integers can be. We have a negative here, and so it's an integer. Okay, and remember, if it's an integer, then it has to be rational, because all of these are rational. That's why rational is the biggest box. It includes them all. And if it's an integer, that means it can be a whole number and a natural number too. No, that was the opposite. Sorry. And number 4 is 10, which is just a natural number. And the natural number would just be counting numbers, which means it's also a whole number, it's also an integer, and it's also rational. And an integer means it's an integer and it's rational. I got a little confused back there. Okay, now you have your practice. You have 4 problems that you need to solve yourself. When you're done, you will let me know, and that is how I will check off your notes. And that is the end of our first lesson.